By 2030, a single technology is projected to inject a staggering $15.7 trillion into the global economy.
Which is just, I mean, it's an almost incomprehensible amount of money.
Right. But here is the crazy part for you listening right now.
Yeah.
Most business leaders are unknowingly poisoning the very systems that they, hope will actually make them rich.
Yeah, they really are.
So welcome to your custom-tailored deep dive. Today we are moving entirely past the superficial hype, like all the sci-fi stuff, to look at the actual concrete architectural blueprints of artificial intelligence in the enterprise.
Finally.
Yeah. We are going to break down the core technology, we're going to unpack how the business models functionally operate, and really just explore the absolute nitty-gritty of project implementation.
Because honestly, understanding these operational mechanics is effectively the cheat code to surviving this shift.
Oh, 100%.
Whether you are an entrepreneur mapping out a startup or a director trying to optimize a supply chain, or just someone insanely curious about the infrastructure shaping our reality, you can't afford to just understand what this tech is.
Right, you have to know how it works.
Exactly. You have to understand how it physically integrates into a business, how it scales, and, where it inevitably breaks down.
Okay, let's unpack this. Before we get into autonomous systems and, conversational interfaces, we have to understand the fundamental trinity driving this whole revolution.
The big three.
Right, the big three. We are looking at the convergence of three distinct pillars from our source deck. First, massive reductions in computing costs. Second, a huge leap in algorithm power. And third, a staggering availability of data.
Yeah.
But, raw elements don't just magically combine into intelligence, right?
No, not at all. They require a highly calibrated environment. A really useful way to visualize this trinity is to look at a modern automated manufacturing plant.
Okay, I like that.
So the computing power, that's the factory floor space and the physical machinery itself.
Makes sense.
Then the algorithm is the automated assembly line logic. It's the instructions telling the robotic arms exactly how to move and when to move.
Okay.
The data then is the raw material, the steel, the plastic, the silicon.
I see where this is going. So if I can jump in with an analogy here, if AI is a high-performance sports car, the algorithms are the engine, the computing power is the chassis, and the data, that's the fuel.
I love that. Yes.
And put bad fuel in a Ferrari, and you're not going anywhere. Or, going back to your factory, if you feed brittle, compromised steel into a state-of-the-art assembly line, the robotic arms just do not care.
They don't.
They will flawlessly and efficiently build you 1,000,000 brittle, compromised products.
And what's fascinating here is how a structural flaw in that raw material creates a catastrophic feedback loop. Specifically, the deck calls this phenomenon the risk of bias loop.
Oh yeah, this diagram is wild. Walk us through it.
So it starts with sampling bias during data ingestion. Let's say you are building a predictive model to identify high-value enterprise clients.
Sure.
If your historical data predominantly features clients from a specific geographic region or maybe a certain legacy industry, your algorithm, fundamentally, mathematically, downgrades prospects from emerging markets.
Because the math is just looking for pattern density, right?
Right.
It just optimizes for what it has seen the most.
Exactly. It doesn't have common sense, it just has math. So that creates a biased model.
Right.
And when that biased model is actually deployed into production, it dictates a real-world action. In this case, directing your sales team to only call on legacy industries.
Oh, wow. I see the trap.
Yeah, so the sales team closes deals in those legacy industries, which generates brand new data.
That gets fed directly back into the system.
Yes, it gets fed right back into the ingestion pipeline. It is a mathematical trap. It systematically blinds a business to new revenue streams while actively convincing leadership that the system is working perfectly.
Because their close rate is high. That is terrifying. And it fundamentally changes how a company has to view data infrastructure.
Yeah.
It ceases to be an IT storage issue and becomes the absolute core of your competitive advantage.
It's everything.
You need a rigorous pipeline spanning data ingestion, processing, management, secure storage, and, APIs for integration. If that ingestion pipeline is capturing garbage, your entire multi-million-dollar infrastructure is just optimizing the speed at which you fail.
Which is a sobering thought. But this transition from merely storing data to actually weaponizing it brings us to the operational reality of machine learning.
Let's get into it.
The source outlines 4 distinct levels of analytics at play here. You've got prediction, automation, optimization, and generation.
Yep.
The critical inflection point for an enterprise like the moment everything changes is moving from predictive analytics to prescriptive analytics.
Which feels like a massive leap in mathematical complexity. I
Hmm.
mean, a weather forecast predicting an 80% chance of blizzard, that is predictive. It just tells you what might happen.
Right.
But a prescriptive system, that acts like a hyper-aware air traffic controller. It doesn't just flag the blizzard, right?
Yeah.
It continuously runs real-time optimization functions to, like, automatically reroute cargo planes, adjust warehouse staffing schedules on the ground, modify supply chain orders all before a single snowflake actually falls.
Exactly. It prescribes the action. But that requires continuous real-time feedback mechanisms. And the complexity, it just increases exponentially when these systems have to interface with human beings.
Well, definitely.
Natural language processing, or NLP, is a prime example of this complexity. Building a conversational interface isn't just about programming a basic search function. It requires fusing natural language understanding, NLU, with natural language generation, NLG.
Right, and I really want to dig into the mechanism of that because it clarifies so much about why these chatbot systems sometimes fail so bizarrely.
They really do.
So NLU doesn't read in the human sense. It vectorizes words into a high-dimensional mathematical space to find contextual proximity.
Right, it's turning language into math.
Exactly. It strips a customer's frantic email down to an intent vector. And then, once it isolates that mathematical intent, the NLG side takes over.
The generation side.
Yeah. It takes those vectors and maps them back to the most probable sequence of words to form a coherent, synthesized response.
And when you combine NLU and NLG into comprehensive NLP, you get systems capable of parsing the actual nuance of a frustrated customer service call.
That is huge.
Right. It categorizes the sentiment, and then it generates an adaptive script for the human agent in real time.
It's incredible. But, parsing text and audio is only half the battle.
Hmm.
A modern enterprise also requires systems capable of interpreting spatial reality, right? Through computer vision.
Computer vision is fascinating.
The functional capability levels of computer vision in the slides scale up in a really intuitive way. They actually use a great visual example of distinguishing between a cat, a dog, and a duck.
Yes, the animal slide.
Yeah. So level 1 is simple classification. You feed it an image, the algorithm analyzes the pixel arrays, and it just applies a generalized label. It's a cat.
Right. It gives you a binary confirmation, but absolutely no spatial awareness. It doesn't know where the cat is.
Exactly. So level 2 is localization. Now, the system detects sharp gradients in pixel intensity to find edges, and it physically puts a red bounding box around the general area of the cat.
Okay, getting better.
Then level 3, object detection, scales this up to find multiple distinct clusters. So now you get separate bounding boxes around the cat, the dog, and the duck, all in the same image.
But the absolute cutting edge for enterprise application, the real game changer, is level 4, which is instance segmentation.
Yes.
Instance segmentation completely abandons the bounding box entirely. It analyzes every single pixel within a region to determine if that specific pixel belongs to the foreground object or the background.
So it's drawing precise outlines around the cat, the dog, and the duck.
Exactly. A pixel-perfect, contour-hugging outline. And practically, for a business, that is how an autonomous forklift distinguishes between a pallet of fragile goods and an empty cardboard box resting right next to it.
Wow, okay. Pushing past analyzing what already exists, though, brings us to what feels like the architectural Wild West. Generative AI, and specifically generative adversarial networks, or GANs.
Oh, GANs are a brilliant piece of software engineering.
They really are.
The mechanism here is crazy. You take two separate neural networks and lock them in a perpetual adversarial contest.
Okay, cage match.
Essentially, yeah. The first network is the generator. Its sole purpose is to create synthetic data from random noise. So generating a completely artificial image of a human face, or maybe a synthetic financial transaction.
Okay.
And the second network is the discriminator. Its only job is to analyze data and determine if it is real or a forgery.
So they are fighting.
Yep. The generator constantly backpropagates its errors to get better at creating fakes, while the discriminator continuously updates its own weights to get better at catching them. It is a mini-max game where they ruthlessly train each other.
Okay, but wait a second. I have to push back on the business utility of this.
Okay, go ahead.
If GANs are literally just two networks trying to fool each other all day, like millions of times a second, aren't we basically just training professional liars? How does a business actually use a liar?
It's a fair question. You monetize the output by weaponizing that deception for structural reinforcement.
What does that mean, practically?
Well, because the generator gets so incredibly precise at synthesizing reality, Businesses use it to create synthetic data to augment sparse data sets.
Okay.
Imagine a manufacturer building a predictive maintenance model for a jet engine. Catastrophic engine failures are, thankfully, very rare,
Right.
which means you have almost no historical data on what a failure actually looks like in the telemetry. A GAN can ingest the limited data you do have and generate thousands of accurate synthetic telemetry variations of an engine failing. Then you train your predictive model on the synthetic data.
Oh, wow. So you use the forgery to patch the blind spots in your actual intelligence.
Precisely. They also use GANs heavily for super resolution. Taking a degraded, low-resolution image, like a satellite image of a crop field, and having the algorithm statistically calculate and generate the missing pixels to render it in high definition.
Or anomaly detection, right, in banking.
Yes. The discriminator network becomes so attuned to the mathematical signature of a normal transaction that it flags a sophisticated fraud attempt the millisecond it occurs.
The scale of this is just hard to wrap your head around. I mean, the deck points out that by 2025, generative AI is projected to account for 10% of all data produced globally.
10%, it's massive.
And that $15.7 trillion global GDP increase we mentioned at the start, it breaks down into staggering regional sector impacts.
Like the Singapore numbers.
Exactly. If you look at projections for Singapore by 2035, the baseline for manufacturing sits at 114.8. With the integration of AI, that is projected to jump to 161.1.
That's a huge leap.
And finance and insurance leaps from 46.3 to 114.8. We aren't looking at incremental operational efficiency here. We are looking at exponential economic transformation.
Yet, despite those projections, an enormous number of companies completely fail to cross the chasm between having a sophisticated mathematical model and actually generating revenue.
Why is that?
They build an algorithm capable of, say, instant segmentation, but they have absolutely no framework for operationalizing it.
Which means bridging that gap requires abandoning the code-first mentality
Right.
and adopting a rigid structural framework. The deck calls this the AI canvas.
Yes, the AI canvas.
It basically forces leadership to define the actual parameters of the deployment before a single line of code is written.
Which is so crucial.
You have to articulate the opportunity, define the specific solution, profile the consumers, map the data requirements, build the strategy, address policy implications, establish success criteria, and explicitly plan for transfer learning.
And we really need to highlight transfer learning because it is the linchpin of modern enterprise AI. It dramatically alters the economics of deployment.
How so?
Well, training a convolutional neural network from scratch, say, to accurately identify defects on a manufacturing line that requires millions of annotated images, massive server farms, and months of compute time.
Which is an upfront capital expenditure most companies just cannot justify.
Exactly. But with transfer learning, you approach it differently. You can think of it like a classically trained concert pianist deciding to learn the harpsichord.
Okay.
They don't have to relearn how to read sheet music or how to move their fingers independently or comprehend rhythm. They just have to adjust to the mechanical weight of the new keys.
I see. So instead of training a model from scratch to recognize, like, delivery trucks,
Mhm.
you take a convolutional neural network already trained on cats and dogs.
Yeah.
Because it already possesses the mathematical weights required to detect vertical lines,
Mhm.
color gradients, textures, all that stuff.
Exactly. You simply freeze those foundational layers, import the model, and only retrain the final output layer using a few thousand images of your specific subject, like the cars and trucks.
It reduces the compute time from months to hours.
Yes.
And the crazy part is you don't even need to own the hardware to do it anymore. The whole ecosystem of cloud computing makes this entirely scalable.
The cloud is the great equalizer here.
Right. You rent access to environments like AWS SageMaker to build and tune those transfer models,
Mhm.
or you plug directly into APIs like Amazon Lex for conversational interfaces, Amazon Polly for text-to-speech synthesis,
Yeah.
and Amazon Rekognition for out-of-the-box computer vision.
You are basically renting an enterprise-grade central nervous system by the hour.
It's wild.
But, and this is a big but, even with elastic cloud compute and transfer learning, the system will fail if it fundamentally misunderstands